Hello everyone, welcome to Electronically Connected. In this video, we will be covering two basic topics of Boolean algebra about how to simplify our Boolean expressions and to go about with it. So we will be covering the sum of products, that is the SOP, and the product of sums, that is the POS, about how it's made, how it's constructed, and how it's helpful for simplification. So let's get started. We know that Boolean algebra is a simple and effective way of representing the switching action of a standard logic gate, like the AND gate, OR gate, NAND gate, etc. that we have studied in the previous videos. And also a set of rules, laws that have been invented to help reduce the number of logic gates needed to perform a particular logical operation, which we have covered in our previous videos. So let's understand what are the different techniques of reducing the logical operation in a much quicker manner. When we multiply two integers, a and b, this is something which is mathematical. But if you want to convert this into a logical form, we AND these two products. So it's a dot b. This is using the AND operation. But if we want to add two terms mathematically and logically, it is the same. But the logic behind it is the OR gate. This product, which is the ANDed product, is called the product term because it's the product, and the addition is called the sum term. Using the product term and the sum term, we have two different kinds of terms that can be formed, which is called first the SOP. This is the sum of product, and the second is POS, which is, yeah, you guessed it right, it's the product of sum. So it's the combination of my product terms and my sum terms which lead to the formation of SOP and POS. Let's understand how SOP and POS come into picture and it's useful for reduction. So let's start with the sum of product. So a sum of product is actually a sum of product terms. So we have A, B, which is a product term, and B, C. So two product terms and the addition of these two terms is called the SOP. So we have a sum of product terms. So it can be multiple terms as well. There are two types of sum of products, which is first called as the canonical form, and then the next is called the standard form. In the canonical form, if we are dealing with three variables, that is A, B, C. So each term, each product term of this SOP should have all the three variables. So if it should be A, B, C bar plus A, C bar, B, let's call this again, and A, B, C. So this is a canonical form. However, there is some reduction still possible in the canonical form. And the standard form can be something like this. Not each term will have all the variables, but it is a reduced form of SOP. It's still an SOP. Let's understand more the sum of products with help of an example. Here we have a truth table on the left hand side. Considering the 1 outputs, we have 4 terms. Let's write down the 4 terms. The first term is, the 0 represents a bar. So A bar, B and C plus A, B bar, C plus A, B, C bar and plus A, B, C. So we can see all these terms in itself is a product and it's an addition of all these terms, hence an SOP. The point to be noted over here is that in the sum of products, each term is a minterm. So the sum of products is actually the addition of minterms. As each term has A, B and C in it, this is the canonical form. Let's understand another way of writing it. This is the 0, 1, 2, third term, 4th, 5th, 6th and the 7th term. Hence, F is the addition of my third term, 5th minterm, 6th minterm and 7th minterm. Because it's a sum of product, it can be written as sum of the minterms, small m, for 3, 5, 6 and 7. So if ever given the opposite form, that write the canonical expression from this numbers, so we can understand 3. That means 0, 1, 1 in the binary form. So A bar, B, C, 5 is 1, 0, 1, and so on. And if we have to convert this into the standard form from my canonical form, so the standard form, standard SOP, is going to look something like AB plus BC plus AC. To get from the canonical form to the standard form, we need to use the Boolean laws that we have discussed in the previous videos. So now let's go ahead and design the circuit diagram using the logic gates for the given expression. So here we have 3 terms. So let's draw the A, B, and C. And for easier understanding, let's draw A bar as well, because the first term we have A bar, then we have B bar and C bar. So the first term is A bar, B, C. So that means an ANDing. 4 AND gates are required. So let's draw the 4 AND gates so that we know where each line is going. And all of these are ORed together. So we have one OR gate and the end. The big OR gate representing the output F. So let's get started. The first AND gate, A bar, B, C. So here goes my A bar and B, C. The next is A, B bar, C. So we have the B bar term, the C term from here, and A, B, C bar. So we have the C bar. This is my C bar. This was my B bar. Then I have my A. And then I have my B. And the next is A, B, and C. So let's just continue A, B, and C. So this is the logical gate diagram for the sum of products. Let's move forward to the next term, that is the POS, product of sum. For a product of sum, let's take the same truth table that we had considered in the sum of product. But the product of sum is a little different from the sum of product. Here, what we consider are my zeros. So we have again 4 terms that will give my 0. And also, the point to be noted over here is 1 is represented as A bar and 0 is represented as A. So while writing the expression, we need to be careful about this. So let's write the expression for F. The first term as 0 is A and product of the sum. So we have to write a sum first. So A plus B plus C ANDed with A plus B plus C bar, because it's 0, 0, 1. Then next term is A plus B bar plus C ANDed with the last term, which is my A bar plus B plus C. So note how A plus B plus C, the product of the sum. So we have a sum and it's all ANDed together, so it's a product of sum. Each term over here, as in the sum of product, is called the max term. Let's see how this can be written again. So we have, this is the first, so we have capital M for the max term, M0, M1, M2 plus M4. This is my F. Another way of writing my sum of product is the sum of product. So we'll write a product term of the capital M, where my terms are 0, 1, 2, and 4. Again, note that all these expression terms have all the terms A, B, and C. Hence, this is the canonical form. And it can be converted again to the standard POS form using the Boolean expressions, the Boolean laws, which will come out to be A plus B, B plus C, and A plus C. So note how not all these expressions, individual max terms, have C, A, or B. Hence, it's a standard POS form. Now let's draw the diagram using the logic gates for the given expression that we have found. So here we have 3 variables, A, B, and C. The combination of these 3 variables give us 4 terms. Each term in itself is ORed with each other, A, B and C. So let's draw 4 OR gates to represent the 4 terms. And the output of these OR gates are ANDed together. So we have one AND gate whose output is F, and the inputs are the output of my OR gate. Now let's create the inputs of these individual OR gates. The first term is A, B and C. So we have A, B and C as my input for the first term. The next term is A plus B plus C bar. So we again have A plus B plus C bar. So we have a NOT gate. Then we have A again, C and B bar. So let's have a NOT gate over here from B, creating B bar. And then we have A bar plus B plus C. So again we have C. Let me extend the wire from B, and then I have A bar over here. So this is the circuit diagram of my product of sums, which is an OR and logic, where my SOP represented was the AND OR logic, because it was a combination of AND gates and then the output were OR together. Let's do a quick recap of both the products and the sum of terms that we have, the POS and the SOP. So the first thing that we covered was the SOP, the sum of product. Each term in the sum of product is called the min term. It can be written as sum of the min terms of my terms. Example of my sum of product is AP plus AP bar C bar. This is the sum of product, where 0 is written as A bar and 1 is written as A. Next, moving forward to the POS, that is the product of sums. Each term in the product of sum is called the max term. It can be written as product of max terms followed by the products that we're talking about. An example of my POS is A plus B plus C ANDed with another term. Both of them can exist in canonical and standard form. In POS, point to be noted is 0 is written as A and 1 is written as A bar. So in SOP, what we concentrate on is the ones, and the POS, what we concentrate on is the zeros. In the next video, we will cover another method of Boolean algebra, that is the K-map, and how it is used to simplify my Boolean expressions in a much simpler and a quicker manner. Thank you for watching. Please like, share and subscribe to my channel. Till then, happy learning. See you next time.